All right, notes, work and energy. And this is describing energy 4.1. All right. Change requires energy. The tennis ball is cruising towards this guy, and this guy is using energy. He is changing the direction of the ball, and he's using energy. It requires energy. Energy in the food he ate, energy stored in his muscles, and it's going to change the direction of that ball. Work transfers energy. So these two guys right here doing a little bit of work. All right. They are nodding their head, and as they nod their head, the ball flies back and forth between them. Okay. They're transferring, they're doing work on the ball. And remember, they're only doing work as long as their foreheads are in touch with the ball. They're doing work. And that little nod of their head is transferring the energy to the ball, making the ball bounce back and forth between their foreheads. Mm-hmm. Yes. Mm-hmm. Of course. Yes. All right. Enough. Systems. Sorry, I had to clear my throat there. All right. So we have a solar system here, a solar electric panel. And what happens here with the solar electric panel? The reason I have this is there's two systems here. There's an open system and there is a closed system. If you see the sun shining on the solar panels, this is locked in right here, and the energy is kept in this house. All right. As it stores up energy and it uses it in the house, that is a closed system. This energy stays in the house. Okay. This energy stays in the house. So the solar energy here is a closed system. It stays in the house. It can also be an open system. All right. It's a little bit of both because any energy that's not used, any of the solar energy not used in here, goes back out to the electric system. And believe it or not, they're probably paying this person for the electricity they're putting into this, the electrical system out here, into the grid. Okay. So they're getting paid to generate electricity for the electric grid. So the closed system is they're using the energy they are gathering from the sun in the house, and then an open system as it flows, extra flows into the grid. All right, different forms of energy. We have chemical potential energy, which we're seeing right here, different forms of energy. The thing to remember is all forms of energy that we will talk about in this class come from the sun. The cow is chewing its cud, and as it's chewing this cud, it got the energy to do this from the sun that grew the corn or the grain, the hay that the cow eats. Um, and the cow is getting its energy from the sun. The sun shines on the food, and then the cow eats the food. All right. Um, Over here, what happens is the sun shines down, and we're going to use the cow as an example. Sun shines down on the food. The cow eats the food. The cow gives us milk. One day the cow's going to die, and if we don't use its energy that it's stored as food for ourselves, as animals in plant material, well, animals in the case of oil, crude oil, their body decays. It turns into eventually oil. That oil is used to form fuel for this car. Again, it is a form of energy from the sun. All energy that we talk about comes from the sun. It gives energy to Bob Ross as he loves on this little deer, and he paints beautiful pictures from the food he eats. The deer gets its energy from the sun, and so does Bob Ross. All the meat, the fruits and vegetables, everything Bob Ross eats for his energy to paint, and that comes from the sun. And here it is, energy all comes from, the sun. Okay? All that energy comes from the sun. Kinetic energy. Kinetic energy is the energy of motion. The word kinetic means it's the word kentos is the Greek word for movement. Let's watch it again. It's so cool. Kinetic energy. Now look, this has kinetic energy, but it's coming from the person that picks the globe up and shakes the globe is transferring their energy into the ball bearings flying around in there. They transferred their energy into those ball bearings and gave us kinetic energy, okay? Here's the equation for kinetic energy. You're going to need this for your homework. It's in the book, obviously, but kinetic energy equals 1/2 the mass times the velocity squared. Kinetic energy equals 1/2 the mass times velocity squared. And energy is measured in joules. So, potential energy. Potential energy is stored energy. Kinetic energy is energy of motion. Potential energy is energy that is stored, and it can be stored in different ways. Elastic potential energy. This woman is getting ready to shoot her bow. Notice the potential here, the elastic potential energy. All right. Now, where's this elastic potential energy coming from? It's coming from her and the food she ate. Okay. She has the ability to cause a change. So she does some work and she adds potential energy to the bow. And as you can see, the sun's in the background. The sun shine down on the fruits and vegetables. Those fruits and vegetables are eaten by animals. If she eats animals or just fruits and vegetables, whether she's a vegetarian or not, doesn't matter. She still gets her energy from the sun. All right. And in this case, it's elastic potential energy. The bow gets its energy from the sun. All right, chemical potential energy. There is energy stored in chemical bonds. And what's happening here is I have two different materials, two different substances. There's the one down in the beaker, and then they're adding this, and it causes a chemical reaction, and it releases the energy in those bonds. It's releasing the energy in those chemical bonds. The way they do this is they add a little dish soap to it, and that chemical energy or the bubbles that form or the energy as it's released gets caught in these bubbles, and it causes this to happen. So chemical potential energy. Chemical potential energy. Energy stored in chemical bonds. Gravitational potential energy. This is probably what you're more used to. They teach you in little school is gravitational potential energy. The higher this guy goes on the steps, his mass is going to have more energy. Here's the cool thing. Let's just say right now his gravitational potential energy is 100 joules. He had to spend 100 joules of stored energy to get from the floor up to here. That energy, as he goes up a step, he's going to use stored chemical energy in his body. And as he spends each joule of that chemical energy stored in his body, gravitational potential energy goes up 1 joule. It's transferred. Energy cannot be created or destroyed, but it can be transferred. Okay, the chemical potential energy of the Snickers bar, we'll say he ate a Snickers bar. The chemical potential energy of that Snickers bar is being used to get him up here, and it's used to increase his gravitational potential energy. And here is the equation for gravitational potential energy. The mass in kilograms, gravity, 9.8 newtons a kilogram, and the height off the ground in meters, okay? Gravitational potential energy.